Can everyone hear me? Okay, so I have the distinction of going last today, so I'll have to make it my job to move things along. My style is more to have a lot of slides, maybe 1 point per slide, so I'm going to go fast and hopefully find some interesting things to tell you about. I'm a project director at AFGG, and I'm currently working on the Expo 2020 project in Dubai. This is my second time in the Middle East because I was here, as mentioned, on the Burj Khalifa project, and I was here as a project director for 6 years on that project while we saw it through execution. So, I actually characterize myself more as a technical design architect. I worked in my whole career about putting buildings together, solving technical problems, and figuring out how to get buildings built. So what I'll show today is as much about some of the work my firm is doing, but as much also about a personal and professional journey of my own. When I submitted my application for fellowship, which I was elevated to this year, a lot of my submission was about approach to execution and a collective design and hands-on type of work. So that'll be kind of my focus on what we talk about. I worked 30 years, more than 30 years overseas. I worked in London, I worked in Dubai, of course, I worked in Shanghai, and of course the USA. So I have kind of a collective experience in working in different environments with different industries all around the world. So let's get rolling here. Okay, so here's the upfront stuff about this being a AIA CES course. I can't see my screen, so I'll look at it this way. And of course, description and the learning objectives. So I put this presentation together, and then I started asking myself, how do I define the learning objectives? So I thought I wanted to create an understanding of various things about complex and tall projects, that being the multiple design considerations when we coordinate these, the importance of working as a collective design, the aspects and project benefits of that industry collaboration, working with other people outside just the consultancy, and the importance of craft quality and execution in built projects. So I think if I tried to sum up what AFGG tried to do, we are dedicated to the design of high performance, energy efficient, and sustainable architecture on an international scale. We work all over the world, and we probably have more projects completed outside the US than in, although we have our one office is based in Chicago. So the firm was founded by Gordon Gill, Adrian Smith, and Bob Forrest. And in 2015, we were ranked as the #1 architecture firm in the United States by Architect Magazine. We have a number of areas of specialities like super tall projects, planning and urban design, cultural projects. Now, a lot of people that know of Adrian Smith's work know that in 1998, the Jin Mao Tower was completed. And this is really one of the first super talls that kicked off the trend for super tall projects being more in Asia and the Middle East, because formerly a lot of tall buildings were built in North America, and this was a shift in the kind of the demographic of tall buildings. And it's still probably the most loved tall building in Shanghai, which is a city of very tall buildings today. There's a little bit, some of our other work is the Burj Vista, which is a project that has a very heavily textured facade. It's about views of the Burj and the Burj estate, but it had a lot of studies in view and solar studies combined to create this sort of texture that works. And it's just finishing, nearing completion in Dubai now. So just one other thing to mention, and it's a really great attribute of working on Expo, and that is our principles of sustainable designs are very highly aligned with what Expo thinks is important. It's really an example project to try to integrate as much as possible higher and higher aspirations for sustainability. And we have a dedicated sustainability engineer. The firm has a director of sustainable design as a dedicated position and we're looking at every material and many, many other KPIs, which are key performance indicators, to monitor how sustainable the Expo project is as a whole. And it's challenging because the industry is not really ready for it, but we're trying to pull them towards something that's a much higher aspiration than the rest of the market is currently undertaking. Okay, so on to my main topic. It's really kind of a case study of the Burj Khalifa. As I mentioned, I was on it for 6 years as the project director, and I brought part of my team over from Chicago to execute the project. As mentioned, it's still the tallest building in the world. It was completed in 2010. And everybody that knows a bit about Dubai and the Middle East can see how explosive the growth has been. There's the Sheikh Zayed Road in 1990. Here it is in 2003, and there's even more density, always pretty much reaching south in Dubai. The original project was based on an old army base, so there was quite a bit of land available. There was nothing there. The army base was abandoned, and the army decamped to further out of Dubai. And this became a project that had really high viability economically and financially for the developer Ammar, because they had control over all of the property on the estate. So all of this here was something that was available to Ammar to develop, and that's really what made it viable. A single tall building like this wouldn't be viable economically. So we started out with a concept design, and it always surprises people that this was a design competition of 2 weeks. And you don't design a building like this in 2 weeks, but you can come up with ideas. So it was a competition of ideas that we won. And there were a lot of aspirations that we had about integrating organic forms, traditional forms, context of Islamic architecture and traditional geometry. So Adrian incorporated a lot of these elements into the design in various ways for the project. So I got there just as we were pouring the foundations. This is the classic hole in the ground where the 3 petals of foundation were poured, and then an center infill. So this is really the footprint of the Burj Khalifa. I'll explain a little bit more as we go about why it's shaped like that. So here we go. It was the first superstructure casting. Here was the tower starting up, rising out of the desert, and eventually a result. At the end of the job, I rewarded myself or punished myself with a climb up inside to the top of the tower. It was the last lift stopped at 600 meters, so you had to climb 200 meters up inside this tiny little tube with a ladder, kind of a thin ladder going up to the top, but rewarded with a fantastic view that you might get flying over Dubai. So this was looking down from 828 meters. I only did it once. So I thought it would be good to talk about Burj Khalifa challenges and solutions. What were some of the things that we needed to face up and deal with? And a lot of times you'll read things about architecture, but you won't read about the problems that we had. And I think it's good to talk about what were the challenges and solutions with complex buildings. So first of all, what made this building possible? Well, wind engineering, structural systems, the integration of those systems in coordination, and construction technology. So these are the kinds of things that make super tall buildings work, and they have to be addressed. As was mentioned, this idea about the integration of structure and architecture in tall buildings is inseparable. Okay? You have to do it, or you can't make it work. So first off, it has to do with structure as a design determinant. Here's a guy that's kind of a metaphor for what tall buildings do. They are very much affected by the wind. There are some regions where seismic is more of a determinant, but in Dubai, the seismic issues are not too much. If you go north to Iran, they're a much greater issue. But in Dubai, it was all about the wind and the collective pressure that a tall building feels when the wind blows. So we looked at wind patterns, meteorological data, and began to understand what would be the effects of wind on the building. So it's pretty well known that the more regular the shape is for a building, the more the wind is going to affect it. So if the wind can slip past on either side and pretty uniformly. Eventually, the pressures that alternate will begin to move the building side to side. And that's where all the discomfort comes from movement in a building, because it's in your inner ear, like you're on a boat and you begin to see sick. So it's very, very important to control movement and dampen that movement in a tall building. So what happens is we have this kind of nasty thing called vortex shedding that comes off the leeward edges of a building when the wind blows past it, and it creates all kinds of turbulence, and it's that turbulence that begins to move the building around. But we find that if we taper the building or change the shape and it's not uniform, then we disorganize the vortex shedding and you don't get effects. You get a quiet structure that doesn't move very much. So how do we know all that stuff? Well, we use the wind tunnel. So the wind tunnel, we use a model. The model sits on a rotating platform, so you can test it from 12 different directions, or as many as you want. And we test for all kinds of things that look at the effects of the wind and how we can determine how to organize the structure to what we say confuse the wind. And so it gets us into the analysis of the frequency of the movement and what kinds of effects we're getting. And what we did was to take the information from the wind tunnel, redesign the structure and the architecture, go back into the wind tunnel, do it again. So it's like a reiterative process that creates a kind of refinement of a less and less wind-affected building. It also gave us a lot of information about what kinds of pressures the curtain wall is seeing, so we can put that into our documents and inform the folks that are going to design and construct the exterior walls. We can tell them what the anticipated pressures are. So of course, you can see at the leeward edges, you're getting the higher pressures from these orange areas, and of course at the top, you get the highest pressures of all. So very, very important information. So the Burj evolved as we designed it. The wind tunnel gave us information. Adrian worked with the team to continue to refine and evolve the building. And at one point, we met with the chairman of Emaar, Mohammed Al-Abar, and we showed him a model. One model had a top on it that was about 550 meters, the original design, and the other top made the building 350 meters taller. He was very excited about that building, and we grew the building 300 meters in one day. But it was really complicated because it gave us a lot of other issues to solve, like lifting and the like. So it was kind of interesting to make it ultra tall from super tall, but it was just part of the challenge that we had to work with. So as a structural overview, we found that we needed a new structural system to make this work. The center core here, which is the kind of the hexagon in red, was connected to radiating arms that went out into the wings, and this became like a stability device. So whichever way the wind was blowing, there would always be a strong direction of buttresses that would keep it from moving around too much. So it had a lot of advantages in this triangular design. And you'll see later that we've also incorporated that into our Jeddah tower, which will be another 200 meters taller than the Burj at least. So, and then from an architectural point of view, it became really efficient to lay out residential units around the perimeter of these stabilizing, stiffing elements that radiated out from the core. So all the verticality was packed into the core. You've got these kind of stiffeners, really what we call a buttress core, very similar to Gothic cathedrals that have these outstretched arms that buttress the walls. This buttressed the core and also helped make it a quiet, less responsive building to the wind. Great for planning apartments, all kinds of flexibility. Mars marketing group really went at it, and we had all kinds of varieties of different types of units, multiple bedrooms that worked into this very flexible plan. So also with the wind tunnel, we were able to predict what kind of issues we'd have with pedestrian comfort because of the surface here getting a lot of downdraft pressure rolling down the surface of the facade, and you would get a real blast at ground level if it wasn't dealt with. So this was a model that was a different type of model in the wind tunnel, and these little dots here sprinkled around give you pressures and effects of wind at the ground level and on the terraces which we wanted to inhabit. So we came up at the ground level with the device for the entrances being these very, very large crystalline sort of glassy boxes that would protect the entrances from the downdrafts coming off the tower, and then also create a very nice lobby space internally, so you can have a sense of arrival instead of just having, a human-sized door at the bottom of the tallest building in the world, which is a little strange. So this is kind of an architectural solution and a comfort solution. And then these are the terraces. This is a model of the wind tunnel. These little guys here read pressures, and then we started coming up with screens that would bisect the terraces and stop blasts of downdraft and crossdraft winds, so that the people who were lucky enough to buy apartments with an outdoor terrace wouldn't have any safety or comfort issues. So this was really effective to measure this kind of thing to mitigate wind on the terraces. And so the result was these kinds of devices here, which are actually downdraft protection and sunscreens, and they're on every terrace all the way up the building. Okay, so I promised Brian that I wouldn't duck any questions about safety or density or tall buildings or anything, so you can have at it later. But we gave a lot of thought to what fire and life safety needed to be. There wasn't a code in the world that addressed this. The Dubai code didn't have anything in it because there weren't such tall buildings. But what we did was we looked around at tall buildings around the world and collected kind of a basket of ideas and solutions that we thought we could incorporate. And so we came up with a number of these solutions, proposed them to the client, and they adopted and accepted all of them. And they're all not cost-free items. They needed specific integration into the building, but they gave us all a lot of comfort that we were doing the right thing to make the safest building possible. And then in particular, we had refuge floors about every 40 stories. So I think there was a question about safety and so on. So if you're on the 138th floor, you're not going to walk down 138 floors. But what happens with buildings like this is we have compartment floors. So the building is actually separated by 2-hour fire compartments. Every floor is separated. But if there was ever any need to get out of a zone, one could come down, 40 floors or less, to an area of refuge where we would have smoke pressurized and air-conditioned spaces for occupants to come down to and stay there. And then at one point, if needed to further manage it, we had the elevators on emergency power to take people down from the refuge zone. So there was kind of a knock-on plan to deal with emergencies and refuge and safety. Okay, and this is just looking at how we call them elevator lifeboats would work from different zones, evacuating people by lifeboat. This is not the typical way to do it because it takes a long time and you wouldn't be able to move a lot of people. But for selected areas within the building, you could evacuate a zone, which we thought was the right way to handle this. One of the other problems to solve in design and coordination and documentation is stack effect. So if you have if you have a building in Chicago where the winters are cold, you will have warm air rising up the shafts in vertical spaces. And it creates pressure differentials, so you're getting a lot of air leaving from the bottom and pushing out at the top just because of the natural stack effect of heated buildings. But in the Middle East, it's the other way around. So we have reverse stack effect, and we have cooling air because we cool our buildings and the climate's hot outside. So we have air pushing down. Now either way, it's the same effect. With this big differential of pressure, it actually starts to seal doors so you can't open them. It stops the lift doors from closing and they don't operate. It's a mess. So we had to find ways to isolate the outside from the inside. So we set up the exterior wall to be very airtight, and then came up with airlocks, revolving doors, and lobbies to separate the outside from the inside and keep this problem from happening. Okay, then Burj Khalifa collaboration technology. I wanted to mention a few things. Now, collaboration is really important, and not just tall buildings. It has a lot to do with just the complexity or size of any project. We all have consultants. There's always specialty consultants. But in the Burj, we had 75 specialty consultants because every type of consultancy had a much higher impact magnitude of importance for getting the building to work. So there was this this is what I mean by a design collective. We worked collectively to put the project together. And then, of course, the contractor had his own issues. They have, with the height and scale and complexity, they had challenges of high-level work environment, material and labor logistics. The fit-out contractor almost went bust because they failed to acknowledge how to deal with material and labor logistics. It was so hard for them to get materials and people up and down the tower during construction. Really a big struggle. But anyway, so these are this is just kind of a summary list of design and construction challenges. I'm not going to read these, but everything has got a system that's got to be integrated, and they all have to work, and they're all key. And one of the things that we did, though, is to work a lot with the contractors to determine what construction systems would work. So they became really almost like one of the consultants to help us resolve this. So all these different technologies that we employed often came from the contractor. And one sort of interesting story is that we had these devices called outriggers. And outriggers are about every 45 stories, and they help the building maintain its straightness and keep it from settling differentially. So it's kind of a stabilizing element. And they're very complex, heavy parts of the framing. So when we designed it, we had this made all out of reinforcing. And we decided, well, we'll figure out a way to do it. But the contractor couldn't. There was so much congestion of reinforcing coming in, all these different angles. He said, let me just build it out of solid steel. And we re-engineered it with them to tie this steel into the ongoing reinforcing in the concrete, because it was a concrete building. And we solved it that way by collaborating with the contractor. Now the odd thing is, when we did the Trump Tower in Chicago, it was the exact opposite. We designed it with the steel, and the contractor wanted the rebar. So it's very important that you work with people who understand construction technologies as well. So this was the formwork system that really extruded the tower. It was a custom system from Austria by Doka, and these little guys would climb the building. They actually we'd put the concrete in, close the form, cast it, and then the form would jump to the next floor every 3 days. So this was very, very fast. And so the fastest cycle was about 3 days, which is pretty amazing. And this formwork system climbed itself all the way to the top. One of our kind of calamities and problem areas was the building wasn't supposed to look like this. Why not? What's missing is the cladding. The cladding was supposed to follow the structure by about 10 to 12 stories. Except the cladding contractor that was finding went out of business. So it was a real problem, and we had to work with finding someone that would pick up a kind of a problem project and come to the rescue, so to speak. So we ended up working with Far East out of Hong Kong to develop a new cladding system. I'll show you a little bit more on that in a minute. And then at the top, working where the building transitioned into steel, from a concrete building to a steel building, we had to work with steel specialists to figure out how to get the spire all the way to the top. And in this case, we built the structure partway up to the reach of the tower crane, and then we had to push the spire out of the framing here to reach its final height. So you can see it's out of the reach of the crane, so it was just pushed right up and jacked into place. We also had to define the exterior wall performance criteria. This is very important, that these kinds of things are not dictated by anybody but the designer and the structural engineer. So working with these kinds of decisions is very important. To choose the materials for durability. Maybe they'll reclad the building in 80 years, but it had to be very durable in the environment for a long time. And testing the facade, we had 15 different sets of tests, including the airplane engine that would push hurricane force winds and water at the building to make sure that the building was airtight, watertight, structurally ready. It's like if you have a defect in a car, you can return it to the factory, and if they call back 26,000 cars, then okay, that's the dealer's cost. But if you had a single design flaw in a panel, you couldn't take 26,000 panels off the building, and there were 26,000 panels. So it was very important to confirm the design before it was put up. So this was what I was alluding to earlier. They finally got going on the cladding, and it went on progressively faster and faster. and ultimately the contractor worked up and caught up with the structure. It's pretty good. So we got a final product out of it, clad. And a pretty nice facade because there's a lot of stainless steel in it. It looks great today, and it's a pretty good choice for durability of materials. Okay, let's see. So the last thing I think I was going to mention is the architectural systems, the complexity of vertical transportation. It's always a challenge in building cores to make them efficient. In this case, it was really tough to do because we had 3 uses in the building. And what happened was we originally had the building with hotel, the Armani Hotel, and we had residential. Most of the building was residential. Imara got a little bit concerned that maybe there was too much of just one concentration. And then once we raised the building to 828 meters, everybody really wondered. And so the client added another use to the building. It was office. So they put the office at the top because of the diminishing smaller floor plates, but it really sort of wreaked pandemonium on the lifting design because they all needed separate entrances. You can't mix office, residential, and hotel. So everything was competing for space in a core. We ended up doing setups where lifts would stack, and so each shaft would be used at least 2 times. In the case of getting people up to the observatory in the office, we had double-deck cabs where people could ride up in a double-deck cab, not knowing they were hitched to another cab above or below them. So it was an interesting solution. Okay, so just touching on a couple of influences and lessons learned beyond the Burj. As mentioned, we're working on the Jeddah Tower in Saudi Arabia. It's going to be 1,000 meters plus. It's got its own challenge as well, very similar to things I've described. It's also a triangular footprint, so we're dealing with wind and looking at the shape the same way. And we're using the wind tunnel the same way so that we're looking at the effects of wind on the facade and what happens with the turbulence and the amount of gathered wind pressure. And it's also affected the shape of the architecture as it did for the Burj. It's carving the shape so that it's got more different profiles that change. It's tapering the tower so it doesn't have a uniform shape to it. And it's notching the tower so that it's removing some of the local pressures at the center. And then of course we're using the wind tunnel to inform us. Also at the base, which is something that wasn't so much a direction on the Burj Khalifa, we're starting to look more at shading and solar opportunities. The Burj Khalifa was a very good building because we believed that there needed to be good energy efficient design. But there wasn't even a LEED building because there wasn't so much focus on that. Now, these kinds of buildings would definitely be a LEED type evaluation and be considered. So we began to look at the base of the Jeddah Tower as a canopy for solar opportunities and photovoltaics, and as a shading device at the same time. So to really kind of increase the amount of shade, but also increase the power generation opportunities was part of what we were doing and what we learned about. And these are studies that look at optimizing the amount of solar incidence on the base of the facade where the solar canopies occur. And it'll be a tall building, and I wouldn't have the nerve to land here if I was a helicopter pilot, but that was the idea. And so the building's going up slowly. It's had a bit of stops and starts, but it's under construction and moving on. The other one I'll show you just as a lesson learned is our Wuhan Tower in China. Also a tapered type of building. Also looking at changing the shape in order to lessen wind effects. But in particular also looking at ways of letting wind pass through edge conditions, which also takes some of the turbulence and leeward pressures off these vortices that generate turbulence. So these kind of relief ports in the edge of the facade, the wingtips, really has a strong effect in relieving the amount of turbulence that's generated on the outside edges. So that was a lesson learned from the wind tunnel and other projects we've done that are super tall as well. and a very streamlined facade. Okay, my last part is just to talk about collaboration in quality craft and materials. This is something that I think personally is very important. I think as architects, designers, people in our industry, we need to follow through more on quality and craft and opportunities to do really good buildings, really durable buildings. So we had a meeting with Mohammed Alivar of Imar about halfway through the project, and he sat us all down. He had to present the design, he had the contractor there, the project manager, everybody. And Adrian and I were showing them what the design was intended to be. The cladding was already going on, so it was a lot more about finishes and so on, and the interior design, landscaping, all this. And then he stopped us partway through the presentation. He goes, okay, I've heard enough. This is what I want. I don't want any changes. I don't want any substitutions. I don't want to make the building cheaper. I just want the best quality building in the world. And Fred Jury said to me, do you hear that? Not the best quality building in Dubai, the best quality building in the world. So we had this tremendous support from the client to try to get a very, very high standard building. And there was an opportunity to make it good quality, integrate craft and art in the details. And this is very, very important, but you have to have people that are kind of in the conversation with you to do that. So you have to follow through with fabricators, manufacturers, suppliers, specialists, everybody that can help you understand and sort out details and materials and the like. You have to check the shop drawings and look at the details and stay immersed and connected to the project and not hand it off to someone that's going to make decisions that you wouldn't make. And so visual mock-ups help. There's all kinds of visual mock-ups that can be done. These are facade mock-ups for a project that I worked on. Material reviews, you've really got to go see natural materials and see what the material looks like. You can go to the source. These are the mountains near Pisa in Italy where Michelangelo got a lot of his white Carrara marble. Go to the quarry and see what the yield is. Look at the slabs and see what kinds of range of materials we're getting. There I personally signed off 42 different kinds of stone on 25 trips to Italy to get it right. So you have to be very present in the follow-through. Doing dry lays of things, important areas like lobby floors and looking at the continuity and the locations and the placement of how stone is used. And in working with craftsmen to develop really nice uses of stone. This is actually over the lift door, and when the lift arrives, the lights come on and shine through this sort of Marshravia script panels that are cut right through the stone, and the lighting behind makes a wonderful effect. So being able to do those kinds of details is a lot to do with working with craftsmen. Same for wood, going to the source. We went to Brazil 3 times to find the hardwood for the project, selecting it and looking at materials. I think I looked at 2 million square feet of this material to find enough. So there was a lot to look at, and really working with materials, understanding what it's like when they're finished, grouping them and grading them, and understanding and getting a really beautiful layout of materials when you do the woodwork, stonework, and so on. Last thing I think is that just an opportunity for art. I think it's great to have significant projects as opportunities for art. This was the main lobby for the residential. It was an art piece. It was a design competition with 4 artists. Jan Plensa from Spain won, and he did this marvelous sculpture called World Voices. So it has 197 gold-plated symbols on these titanium rods. There are jets of water that shoot down from the ceiling and make the cymbals ring. And there's it's called World Voices because this is the kind of each symbol has a sound to make. So it's very nicely done. So my last point, and maybe my big point, is that really good work is about collaborative success and how well we work with owners, how do we work with consultants and contractors, and really find ways to solve problems and develop great solutions.
Okay, any questions? George? We have a mic coming here.
When pouring the concrete, how did you actually pour the concrete, get concrete up to the top?
That's a good one. It was actually pumped up, And it was a hard plumb system, so they had a pipe that was about only 250 millimeters in diameter. It was attached to the core wall, so it was this big red pipe. And every night they would start the pump up, and they would pump the concrete. And they pumped it all the way to 611 meters, so it's a world record for pumped concrete. But the concrete was very special.
Change the formulation? Or
Exactly. So it was it was more chemistry than engineering. And so when you do that, you want the stuff to flow like liquid, very liquid, but you want it to set up very quickly, hydrate very quickly, and have early strength very quickly, so you can build on top of it in very quick course. So it was a very interesting mix of concrete. I'm not a concrete chemist, but it also had to be self-compacting because there was so much concrete being poured, they didn't want to have to vibrate it. And it had to be kind of just fill all the voids and run in between this. The rebar was very, very concentrated, so it was kind of this very, very special mix. And it couldn't set up in the pipe while it was going up, So that was a good question.
Azam? Hi. Sort of a two-part question. So, the decision to move to a concrete structural system for super tall buildings, was there precedence for Burj Khalifa beforehand? And the reason I ask, which is the second part of the question, moving from where super tall buildings were before in North America, they're mainly or almost entirely out of steel, and then the move to the Middle East and then I think even Asia, it switched to concrete. Now, is that technological innovation that occurred recently, or or is concrete better, or what were the decisions that led to concrete?
That's a very good question. It's a little bit like the example I made of the outriggers and how we handle different options for how to connect outriggers working with the contractor. But in the Middle East, it's sometimes just driven by market. So in the Middle East, there's more labor that allows you to handle the form work and do that kind of thing. With steel work, it's very much more precision. So you're having someone at a mill cut and shape and make all the connections in the steelwork before it comes to site. So it's more precision driven, and labor costs are higher for that. So it's partly anywhere you go in the world, you'll see different markets supporting different ways of doing structure. So probably in the U.S., yes, you used to see everything in steel, Empire State Building, all those classic old photos, everything was riveted steel. But now probably it's a mixture of both in the U.S., and then people are also working with hybrid structures now where you're seeing a combination of hybrid concrete and steel. So I think it's a real specialization to be able to determine if within any given market, do you want all concrete, all steel, or a combination of both? It's very interesting part of our industry right now. So it's mostly though driven by just local technology and labor costs and things like that. One thing I will mention though is one of the reasons the Burj was such high speed is that they set up a rebar farm on the ground, and they had these guys working assembling sort of wall-shaped cages of rebar. And once the reinforcing was all tied together in a cage, they would lift it straight up to the top of the building, they would drop it into the form, and then the next day, after they got the shutters and everything aligned, they would cast that. And then the cycle of being able to have guys working on the ground and not on the top, wiring rebar, sped up the whole cycle time. So it was really efficient that they were able to work that way.
Question? Rowan will take you next. Yeah. Okay.
Thank you very much. I have a question regarding such great, huge, mega-scale project. Definitely it will lead to sort of invention, discovery, and so, Dubai by itself, not only Burj Khalifa, led the architecture world into a new era due to the material, design, and so on and so forth. In this project, is there some techniques, inventions, formula? If there is, do you have a count? And if you have a count, where can we find it?
That's an interesting question because the one thing that was kind of distinct about the Burj was we didn't use any technologies that hadn't been used before. because it was such a special and unusual building and nobody had gone that high, there was an anticipated idea about avoiding a certain amount of the risk of a new technology or a new material and so on. But what we did was we used a lot of existing technologies in new ways, you know, to take it to new heights. But there wasn't a lot of adventurism in trying something that had never been done. Certainly with the contractors and everybody, we pushed the envelope, so to speak, and took it to extremes of complexity and construction technology, but it wasn't so much innovative in the sense of each component. You know, the elevator technology was pretty much the best we could get. The concrete technology was the best we could get. A number of those kinds of things, the high-performance curtain wall, we use high-quality glass for the double-glazed units, and the focus on keeping out solar radiation and reducing that energy load. Those were all very much using the most current available products, but there wasn't something new that it was kind of a risk element, I guess I would say.
Further questions? Lady at the back and then lady in the center.
First of all, thank you for your presentation. It was definitely very informative. You spoke a lot about function or form following function and necessity driving certain elements being added to the design. I feel like there's this never-ending struggle between form and function, and whether you design for which one comes first. And I think there's a question for all these speakers from today. How do you, as a designer, keep yourself in check? And I guess design in a way where you're not just focused on one, and you're not allowing, let's say, struggles or issues that come up throughout the process to completely push away your initial design or your conceptual design. And is it okay to design things that just because they look cool? Is that a good enough justification to create things?
Good question. I think our current design direction, working with Adrian and Gordon Gill, is that it's really more of trying to be a more performance-driven form, and the form should be a response to what we're trying to make the building do by raising the performance levels. So if we talk about wind engineering, what's the response of the shape of the building to wind pressures and those kinds of things, rather than what looks cool as a tapered tower. They do look nice because they kind of, I think the Burj looks a lot like a super tall building should look. It's got kind of a nice elegance to it, but it's also very high performance. So I think where we're trying to get to is that things are more performance driven with all the different systems, and looking at things like how do we raise the performance level rather than the form versus function. So that the function, it obviously has to be met, but it's really looking at performance terms.
First of all, thank you for your wonderful presentation. My question is that what is your design philosophy, and is it stable or it changes for every different project as you move on?
The idea is that we aspire to diversity in design. I think David put it earlier that we really look at each project on its own merits. What is it trying to do? Where are we trying to build it? How do we achieve this by looking at this performance driven and just responses to environment, the culture, all these kinds of things. I think it creates a diversity of expression. I really like Renzo Piano's work because all of his buildings are different, and he doesn't have a style that you can recognize, but they all look like they've been thought through and have a very strong performance and a responsiveness to whatever the building needed to be. And I think that's where we all try to be, should be.
I have another technical question. Working in this region, I had many problems with stainless steel. On the Burj, you said that you use a lot of stainless steel, so I was wondering what type, what specification, duplex, 317.
Right.
And what's the finish that you put on?
That's an interesting question too. We had recently attended the CTBUH conference in Dubai, and they had a very good stainless steel specialist there, Otto Kumpu, and they're a German outfit. And when we did the Burj, you could only get a certain grade of stainless steel. So we used 316, which was kind of like the ultimate grade. And now, since the Burj, they've come up with all these new alloys that do different things, marine environments or possibly industrial applications and so on. So there's a huge amount more of choice when you work with the new alloys that are available. So we probably have a whole range of new choices. But at the time, 316 was the thing to use outside, and it's held up pretty well. Imar really maintain their properties well. They look after their investments. So if you take care of buildings, they're much more durable. But we didn't have a huge amount of choice except the go-to metal at the time. Now it's much better.
Okay, great. Thank you very much, Eric. Big round of applause.